Right, now vectors and vector geometry is something which a lot of people say, well, what's the point of this? Why are we doing this? And one of the reasons they say that is because it's tricky. And when you see something tricky and it's just all a bit abstract, you wonder why. So I'm calling this video Route Planning is the Veritable Purpose of Vectors. Veritable meaning true. So the real reason for it is about route planning, and it's very important in terms of planning out how you're going to deliver all sorts of different logistical things. So anyway, here's our first here's our first situation. The question's not written down yet, so copy this down and have a little think about what's going on. One thing you might want to notice is they've suddenly put this thing of a ratio in. A to P is 3 to P to B is 1. So what fraction does that mean P is on the route from A to B? That is going to be key. So here's our question, or our two questions, and vectors questions are nearly always, because vectors is a grade 8-9 topic, but very often they give you 1 or 2 easy marks at the beginning, which I reckon anyone can get. The second bit, not so much, but it's still gettable, and there are marks along the way that can be got there. So let's have a go. Pause the video and see if you can work out what AB would be. So going from A, I've got to go against, to get up to B, using just A and B, I've got to go against the A and then with the B. So against the A is going to be minus A, and with the B is going to be plus B. So I'm going to write B minus A. But if you wrote minus A plus B, that would be fine. Now, to get from O to P, that's tricky. But the fact that the reason they gave us AB in the first place is that if you consider this, I'm going to put this in first of all, we actually need, if we know how to get from A to P, A to B, we can also do this. We're going to use that. So AP is the next one we're going to do. And do you remember what I said about the fraction? If I was to go 3/4 of a negative A, that would get me about to there. And then if I was to do 3/4 of doing B in that distance, it's going to get me to there. So if I call that 3/4 of B, and that minus 3/4 of A, that is going to be a real key thing to use. So going from A to P, first of all, is going to be 3/4 of B, take 3/4 of A. Then, as I know how to get from O to P, O to A, I can, although it would be a very long-winded way of doing it, I could say it's going to be the same thing as OA to get me to there, plus AP. OA is just A, isn't it? So I'm going to replace that with A, and I'm going to replace AP with 3/4 of B, take 3/4 of A. And actually this question would probably have told you to leave your answer in its simplest form, because there would be one final mark for sorting out your A's. If you go 1 whole A positive and then take away 3/4 of it, it's just the same as 1 take 3/4 is 1/4, isn't it? So 1/4 of A plus 3/4 of B. And that would be correct, but you could, if you wanted to, factorize. That would make it a bit nicer by taking the quarter outside. 1/4 of 1 is 1/4 A, isn't it? And 1/4 of 3 is 3/4. So you could do that. If you wanted to show off a little bit, that would be really nice, but this would also get you full marks. Okay, that's our first example. I'm going to introduce each question a little bit at a time rather than putting all the information down there. So have a little look at that and copy it down. It says ABCD is a trapezium. Now that's important because that means that these two sides must be parallel. And that means that we don't know how many times bigger this is at the moment, but that means that because this is in the same direction, you will be able to multiply the vector p by a certain number, and that will make DC. And you could divide whatever the vector is for DC by a certain number, and that would get you to p. That's going to be key. Next bit of information is that DC, so that length there, is going to be twice the length of AB. And the next thing that they always tell you is they will say AB equals P and AD with a little arrow over it equals Q. That's kind of obvious, you can see it from the diagram, but they always say that, so I thought I'd put that in. Okay, here's our first question. Hopefully, now that I pointed to the 2 to 1 bit, you can get this. So it is the same direction as that, and it is twice the length, which means it's going to be 2p. P plus p is 2p. If you wrote p plus p, you'd get the marks because it didn't say in its simplest form. So you could do p plus p or p times 2. So here's our final question on here, finding BC in terms of P and Q in its simplest form. So have a go. Do it without simplest form first of all, and then simplify. Right, so if you've had a go, now so BC, it really is a good idea to draw on what you're going to do, because it makes it really obvious when you've got negatives involved. It's very easy to go a little bit wrong. So we already know that DC is 2p. From B, I've got to go round here. I can't just go sort of straight across that. I've got to use my P's and Q's. So going against the P will give me a minus P, going from, in fact, I'm going to write it out. Sometimes it's a good idea to talk about your whole journey all the way through. So BC, if it asked you to show Y, then this would be the thing to do. B is, I'm going to go B to A, then I'm going to add to that A to D, and then I'm going to add to that D to C. So that's going to give me B to A, it's the opposite of A to B, so it's minus P. A to D is plus Q, and D to C we've just worked out is 2p. So then I just need to simplify that by adding my negative p to my 2p, which just gets me one of them, which gives me p plus q as an answer. And what that means is, now that I've done the great thing about the simplification is, it would tell me that the route I could take could be much, much shorter. And all I really need to do to get there is do a P shift, which would be like that, and then a Q shift, which would be like that, and it would get me to C. Okay, that's that one. Right, so here's the whole setup and the first part of your next question. So take your time, jot it all down, and pause the video and have a little go. Right, we just want to go from A to B. So going from A to B means I'm going to be doing that, doesn't it? Which is going against the red arrow. So that's going to be minus 2a, and then it's going along with that one there, the 3b. So AB is just going to be 3b take 2a. That's all it is. So part B though is going to be to show that OP is parallel to A plus B. Right, so what would you do first? Pause the video and have a little go if you can, see if you can do something for it. And in order to do it, the first thing we need to be able to do is define O to P in some way. Well, what fraction of the root from A to B is P? Because of this, you've got two parts there, haven't you? And then you've got your P, there's your A. Then you've got three parts afterwards to your B. So that looks like 2/5 of AB to me. So that's the first thing that I'm going to work out. AP is 2/5 of the one they've asked us here. And it always happens that that easy one at the beginning is part of it. So it's 2/5 times that. That's AP. Now we want OP. And OP, a bit like what we did last time, we're going to go from, it's going to be OA plus AP. And if it's parallel to, oh, let's not worry about the parallel bit yet. Let's just define this as we can. So OA is easy, isn't it? It's 2A. And AP is all of this. Now, I think I'm going to need to do some simplifying later. So I'm going to expand this bracket now when I write AP down. So 2/5 times 3 is, well, 2 times 3 is 6, isn't it? So that's 6/5 of B. And 2 times 2 is 4, so that'll be minus 4/5 of A. Now, if I simplify this, which I can do, if I consider that 2A is the same thing as saying how many tenths? Well, 5/5, sorry, how many fifths? 5/5 plus 5/5 makes 10/5, doesn't it? So I'm going to say 10/5, because then 10/5 take 4/5 is 6/5 of A plus 6/5 of B. And now we're virtually there, because remember what I said to you before about factorising? That's the same number, multiplied, albeit a fraction, multiplied by A as B. So we can then say 6/5 of, and put A plus B in the bracket, just about room on there to see it. And we've done it, we've showed that it's parallel, because remember what I said before, if something is parallel, then there will be a multiple of it, will get you from one to another. Right, have a look at our final question for today. This is a real humdinger, folks, so if you can get this, I'll be really impressed. I haven't put the question bit on yet. You've just got the information. So we've got a parallelogram. We've got the vector from K to L going in that direction is A. That should also mean that that is A. And from K to N is B. So being a parallelogram, same length, and parallel L to M will also be B. O is the midpoint of the line KM. Well, let's hope that doesn't cause too many problems. And express OM in terms of A and B. So we need to get from O. So we'd better put O in. So have a little go at sketching it in before I do. So the line KM is going to be straight from there to there, and O is going to be the midpoint of that. One way we could find that is to draw the line in across there. I'm just going to, and that would give me O there. Now, how do we get to from the midpoint? Well, the midpoint is going to be half the distance across, isn't it? So OM is going to be half of KM, isn't it? So it's going to be half of KM is, well, going along A, and I'm going to put in that that's B on my thing. Remember, you can write on your diagrams at all as you go. So I just go up A across B. So it's a half of A plus B. So if it's a half of that, O to M is just going to be that, isn't it? You can leave it as that, or you can say A over 2 plus B over 2, or a half A plus a half B, whatever rocks your boat there. Right, that's the first part, the easy part. And here's our final bit. So we've got, have a little read of it. I'll be quiet for a moment. Okay, so it's the point such that NMX is a straight line. So if X is coming afterwards, we can go up there. So we know that we can continue this on. Now maybe I'll take a different colour to do that. And the X is going to be at some point along here, at some point. But it also tells us that we've got this ratio K to 1. Well, let's not worry about that so much because we've got this information over here. Let's get worried about this. And actually, this isn't too nasty. We know that the shift from O across, that was a half B. Make a drawing. If you get confused, this is a creative topic, definitely, vectors. Get drawing on here. There is an A. So half an A gets me to there. A gets me to there. I'm going to put a dot there where one A's gone. I'm going to do another A to about there. And another A. Up we go to about there. So that is 3A. And then a half of B. A half of B is going to take us over to about there. Little arrows in it. So if I continue this along, that is where X is. And what we want to know is the ratio of this distance here compared to this distance up here. We're calling this 1. Well, don't worry about calling it 1 yet. Let's just find out what it is in terms of what we know, which is A. So it takes, and the little bit where you could make an annoying mistake here, the first time I looked at it, that's what I did, is remember you've got half of an A there. First time I did it, I took a whole A off, don't know why. If I take a half of an A off, what have I got left here? 3A, take A over 2, taking a half off is 2.5 A, isn't it? So what does that mean? If we said that this part here, NM to MX, well, we know that that's A, and we know that this is 2.5A, which I'm going to write as a fraction 5 over 2A. Well, the first thing I could do is get rid of the A's. How would we do that? Divide both sides by the same thing, just like you would do with an equation or a fraction to simplify it. A divided by A is 1. 5 over 2A divided by A is 5 over 2. Now I'm running out of space, so let's go over here. So we've got 1 to 5 to 2. Now we need to get it to something to 1, because that will give us our value of K. So all you need to do there is divide by whatever the value is you've got here. So if we divide by 5 over 2, that's going to give us 1 divided by 5 over 2. Well, stay, change, flip means we've got 2/5 to 1. So therefore, k equals 2/5 or 0.4. Now that was a nasty one in a way, but it wasn't that nasty once you start drawing it out and take charge and don't mind what you're drawing through as you go. Well, I hope you enjoyed that almost as much as I did, folks. And we will be going back onto our favourite free website for resources and doing some real GCSE style questions over the next couple of lessons. So we've got that to look forward to. Cheerio, everyone.